Hello, class, the receiving students and teachers. You may be seated. As usual, we will recall our previous lesson. Previous lesson, we looked at the law of the lever. Now, I'd like someone from the class to tell us what is the law of the lever. Receiving students, you may also tell your teacher. Yes, Tulanga.
The force times its distance are equal on both sides of the fulcrum.
Very good, thank you. Receiving students, I hope you did the same. Teachers, we are still on the same strand, same substrand and outcome. Now, class and the receiving students, I'd like us to have a look at the picture we have. And you can quickly talk about it, and I'd like someone to tell me what the picture shows. Okay, this is a simple machine. I'd like someone to tell me what that simple machine is. Thank you, Quarry.
Pulley.
Very good, thank you. It's a pulley. Now, our lesson topic is pulley, and this is the first lesson on pulley. We will have 2 more lessons on pulley as well. Now, the first lesson that we are going to have is on single pulleys. Besides the single pulleys, there are different types of pulleys, and they are used for different purposes. Some are for loads that are not very heavy, and some for very heavy loads. So these different types of pulleys are used for different types of work. Now, what is a pulley actually used for? What is a pulley actually used for? Receiving students, tell your teacher what you think the answer is. I seem to be having all the boys. Let me have one girl. Violet?
It is used for sending energy and motion.
For sending energy and motion. Anybody else besides Violet? Pulleys? What are they used for? Receiving students, I hope you are telling your teacher what you think pulleys are used for. Okay, let's have Shane.
A wheel that carries a flexible rope, cable, chain, or belt on its rim.
Okay, good. Now, when we do our activity, the activity should help you to know what pulleys are used for. Now, our activity teaches the strategy that we will be using is shared learning. In this strategy, students will be working in their groups to do the experiment, and after they have done the experiment, they will come together to make a big group, and they will share together what they have found out or their findings, and they can discuss. If they find that their answers are different or the results are different, they try to discuss together to come up with one answer. Now, I'd like to have the runners from every group to come up and collect your materials. Runners, please. Thank you, Helen. All of them. Wait, I will tell you which one to get. Get that. Helen? Okay, Carol, take that. Get this. Make sure that one stays. You have to take this one too. This one with you. Here. Now check to see that you have a retort stand. Is this one you have? I have the metal one. Some of you have a retort stand that is made from timber or wood. You should have a meter ruler, a spring balance attached to wire, piece of wire. You should also have the piece of wire going over the pulley. You should have some weights with you. Okay, this one, some of you have this, the 500 grams one. Some have this. Okay, this is equivalent to 500 grams. So some you have this and others you have this. And everyone should have a 100-gram load or a mesh with you. Now our first part of the activity is to set up the apparatus as shown. Class, you have the worksheets with you, so you should be able to see the worksheet. Receiving students, that is how you should set your apparatus up. The diagram should help you to get your apparatus set up. Now you are to put a mark on the retort stand 10 centimeters above the base of the stand. Now a third part of activity is on. I'd like the class and the receiving students to take note of that activity, the third part, and do what it says. Everyone together in the group will discuss, and you work on what the instruction says. You will be working, okay, you're going to be working on listening. You're going to work on 500 gram, only that. Okay, you only work on the 500 gram. Okay, you are also going to work only on the 500 gram. This is going to be done by the others. Only the 500 gram. Okay. You should have a ruler there with you. Now, can I have Tulanga, if you can read for us the third. Okay, so you are beginning the activity, so you have to take the mark of the load and the effort of the distance before you start. So that's your load there. Now, you're not going to lift the load up. You have to take the mark of it. So what do you do to take the mark of that load? Can somebody tell me how you take the mark of that load? How do you take the mark of that load? This is the load. How do you take the mark? Come on, someone tell me.
It's a easy load. When you get the load,
Yes, Patricia. This one doesn't go right up there where the 10 centimeter one is. What do you do?
Get the
Yes, Aaron.
get the spring balance part. Pull it and get that.
Okay, you try it and we see. Harold is going to try it. You are still with the second one. Okay. Stand up. You stand up and do it. Now, okay. He doesn't pull it right up. You pull it. What's the grams now? No, the weight doesn't go up. Okay, what is it now? Jennifer, what is it now? 500. Now, if 500 grams to Newton would be how much? 500 grams to, you convert it to Newton? 500 grams, you convert it to Newtons. Okay, so somebody have it written. Let's now how do you get your effort? Effort from start? Huh? This is your effort side of the string. That is the load side of the string. So how do you get your effort from start? Yeah, there's a ruler I brought for them to just put it where the 10 centimeter line, so when the weight goes. I put them in the what? 5 of them, 6, 4 of them, but they are not. Rulers I brought. Wait. Goes to the one to that group there. Now you are. Did you get your load at start? Did you get your effort at start? Have it written. Your load at start and your effort at start. You are pulling this, so this is the effort, this rope here. This is the load side. Now, you pull it, you said it's 500 grams, okay, which is equals to 5 Newton. So, you hold it to 500. Let me see them first. Did you take your load and effort at start?
1.8.
Okay, load is 0 and effort is 26. What's your effort and load at start? Your effort and load at start? What did you get for your effort? Your load at start and your effort at start. What did you get for your load and effort at start? 3.5 and effort? Okay. You haven't started measuring yet. Don't forget. You haven't started doing your experiment yet. You have to know your effort and load at start. So once you start doing the experiment, okay, and once you get the experiment going, you see the effort, how much it comes down. You count that one. You are going to take whatever you get away from the 0.3 you have. And then what you have is going to be your effort. Same as the load.
About 5 more minutes.
Now you should have all got your load and effort at start. Our next instruction, follow that. Our next instruction. What is the next instruction? You see that and you follow it. What does the next instruction say? Okay, to simplify that, read what is there. Okay, so what are you going to do now? What are you going to do now? Well, you haven't gone to that part yet. What does the instruction say? Work done on load is, what did you get? Work done on load. What did you say your grams was? Oh, sorry, not that, sorry. Effort needed. Okay.
700.
You're not using 700, you're using 500. 400 grams. So that 400 grams is equal to 20. Okay, so that's now work done on load. You don't go to that yet. Work done by effort. You don't go to that yet. You have to look at your effort needed, distance moved by effort. So where it says effort needed, you have it recorded there. Have it written there. You all have your worksheets there. Effort needed, what did you say? 400 grams. So 400 grams, when you convert it to newtons, have it written there. No, not that you are doing 500. That 100 is for another group. 400. Here, 4 newton. You are writing it in newton. Okay. Our next instruction is up, so you see that and follow it. What does the next instruction say? You already got your effort needed. Now, when you lifted that, when you lifted your 500 gram up, the effort on the spring balance, you are using it as your force meter. It's telling you how much effort is needed, okay, to lift this 500 grams. So you said it's 400 grams, which is equals to 4 newton. Now you lift it again, so this time you are going to see the distance moved by the effort. Okay, if you can do that. No, you hold it here. Your hand is here. Okay, and then pull it. You should have a ruler. Okay.
400 there, 400 there. Stop at 400. Why looking 400 next? You want the man? 400. Okay, look it up. Listen, man. Listen here. Come, relax. Okay, stop there. You see. Wait. Okay,
Your ruler goes that way. Okay, somebody hold it. That one mustn't be going up. It must rest on the. Wait. Try it again.
Wait.
Try it again.
Okay, 400.
Let's see. Okay, let's see. You already got your effort needed. Now you are going to find the distance moved by the effort. Okay. To find the distance moved by the effort, you see that is your distance moved by the effort. Okay? So from here, you take the measurement. Now, to do that, you see you have to move it closer. Okay? So you see where it stops. Example, say if it's here, 28,
Count it up.
and we say about 57. Okay? So from 28 to 57, you start counting 1 centimeter, 2 centimeter. Okay? Do that.
Start at 33. Start at 33 and finish on time.
Okay, somebody, you see the number now?
Yeah, you only start cleaning. 57.
Okay, so 25 what? 25 centimeters. But you have to convert that 25 centimeters to meter. So what do? Because 10 centimeters is equals to 0.1 meter. So if it's 25, 0. You don't say 25, 0. You have it recorded. Effort. Distance moved by effort. Here. You are still with 500, not there. Here. 0.25. I hope you have recorded your readings in the table. You are trying to find effort needed and also distance moved by the effort. So you should have recorded your effort needed as well as the distance moved by the effort. Now let's see how we calculate the work done and also work done by the effort and also work done on load. If you remember our previous lesson, To find work done, we use the formula work equals force times distance. So I'd like you to find the work done on the load and also work done by the effort. Now, what you do now, listening here, your work done on the load is 4 Newton. Now your formula is what is the formula? What? Work done equals force times distance, okay? So you should do that to find your answer. So get that one done. Just have the formula done, written here. Work equals force times distance. Or just W equals force times distance. Now there are many of you, so some of you work on work done on load and effort needed, and some work on this one here. Okay. Now, when you look at work done, okay, you have work equals force times distance. What is your work there? What is your work done there? Sorry, your force. Force, don't forget, is the distance. Oh, sorry, force is the work done on the load. So what is the force applied? 4 newtons times distance. What's your distance? No, look at your distance. 0.1. So you're going to multiply with that to find your answer for work done. Okay? Not that. 4 Newton. You work on that to find your answer now. Work equals force times distance. Yeah. That's force. Okay. Effort needed is the force. Times the distance. 0.1. You multiply that. Yeah, multiply that.
aku cerita.
Where?
Oleh kisah di sana.
From group 1 and Jennifer from group 3. I'd like you to get yourself prepared to have your results written on the big results table that I have in front of the class. Shane, you are working with the 100 grams, which is 1 Newton. Jennifer with the 500. Record it here. Come and write it up there. Your answers. You can have your answers recorded there. There's the marker there. Thank you. Let's save our Jennifer for the 500 gram or 5 Newtons. Thank you. That is what we have from the groups with the 500 grams, which is 5 Newton, and also 100 grams, which is 1 Newton. Now, I'd like to have Shane to quickly tell us how he got his answer for work done on load.
We multiplied the the amount of force, which is 100 grams, we converted it to newtons, is 1.0. Then we multiplied it by the distance, is 10 centimeters, but we converted it into meters, which is 0.1 meters, to get the answer 0.10 joules.
Very good, thank you. Let's have Jennifer to tell us how they got work done by effort. Jennifer,
We multiplied the 4 newtons by the 0.25 centimeters, and we got the 1.00 joules for our answer.
Okay, thank you, joules. Okay, thank you, Jennifer and Shane. Now we go quickly through our summary. It says single pulleys can only be pulled downwards. Less force is applied when pulleys are used in lifting loads. Pulleys do change the direction of the force. 4, pulleys are used to make work easier. A key phrase for this lesson, making work easier. Our next lesson, teachers, is going to be still on pulleys. Second lesson on pulleys. We will be still using the same materials that we have used in this lesson. And with that, thank you, class and the receiving students, for your participation.